Assalamualaikum. We'll meet again. Now, ladies and gentlemen, let us warmly invite to our distinguished guest for speaker slot 1 this morning, Mr. Meor Mohamed Haris bin Meor Hussein, ex-director of Policy and Corporate Management Branch, Malaysian Public Works Department, JKR. On this virtual platform, welcome to the International Construction Industry Week at FTK 2022 Slot 1 with the title UHPFRC for Bridge Superstructures in JKR Projects. Without further ado, it is now my pleasure to invite Encik Abdul Zaki bin Abdul Wahid, moderator for today, to lead our webinar. Sir, the floor is yours.
Assalamualaikum. Is it okay, everything?
Yes.
Okay. Assalamualaikum. I've been talking to a screen without being on meeting. Sorry for that. Good morning to all. Welcome to our first session of ICIW FTK2022, hosted by the Faculty of Engineering Technology, UTHM. Our previous ICIW event has been a success, and I hope that today's session will kickstart another success journey for our faculty, our guests, students, and participants. My name is Abdul Zaki bin Abdul Wahid. I'm academic here at FTK and will be serving you as your moderator for the sessions today. You'll be hearing a presentation from our honored guest, Mr. Meor Mohamed Haris bin Hussein, ex-director of Policy and Corporate Management Branch, JKR Malaysia. But before we get started, I would like to inform you that if you have any questions during the presentation, you can write them down in our Zoom chat box, or you can ask your question at the end of the presentation in the Q&A session. So back to our notable guest, Mr. Meor. Mr. Meor started his career at JKR Taiping 43 years ago, almost as old as me, in 1979, and retired from JKR HQ in the year 2018. Congratulations. Throughout his successful career, Mr. Meor has served as a civil engineer, managing many medical facilities and public infrastructure projects at various JKR's civil engineering departments, most of them in the state of Perak, and also at the federal level. Mr. Meor has also contributed a lot in the energy efficiency and sustainability sector during his engagement as a senior engineer at KETA. So, moving along to our session, please welcome Mr. Meor Mohamed Haris Meor Hussein, who will be speaking to us on the topic of ultra-high performance fiber reinforced concrete. A bit of a tongue twister, UHPFRC for bridge superstructures in JKR Projects. So, Mr. Meor, dipersilakan.
Can the slide be seen on the screen?
Okay, clear.
Okay, right. Thank you so much, Mr. Abdul Zaki, for the brief introduction for myself. Assalamualaikum and very good morning. Okay, the topic that I'm going to present this morning is, as mentioned earlier, is ultra-high performance fiber reinforced concrete for bridge superstructures in JKR projects. In the presentation, okay, let's go for slideshow. Okay, the presentation consists of 5 main items, which are, number 1 is the introduction, which briefly touch on the development of ultra-high performance fiber reinforced concrete and its application as a structural component by countries in the world. Item 2 is the development of ultra-high performance fiber reinforced concrete in Malaysia. When did it come into existence? and the establishment of the company, who owns the product, and who is the founder and the CEO of the company, and when did JKR first knew about this new concrete technology and JKR first application of the product for bridge superstructures. Okay, item number 3 will be on application of ultra high performance fiber reinforced concrete beams in JKR projects, and as well as the achievement by JKR in terms of the implementation. He also briefly described the design mix used for the bridge superstructure, the lab tests associated with the design mix, okay, the material characteristic values and results, as well as durability tests, standards used for design, and also inclusion of the requirements in JKR roadwork standard specification for section 9 for concrete. Okay, item 4 will be describing the advantages and benefits of ultra high performance fiber reinforced concrete against normal concrete. For instance, it is lightweight, durable, environmental impacts, life cycle cost saving, and longer lifespan, including the cost implication of between the new concrete technology as well as normal concrete. And lastly, item 5 will be conclusion, which describes JKR's contribution in the application of the product. Okay, let's go on to item 1, introduction. The ultra high performance fiber reinforced concrete was one breakthrough in concrete technology in the 20th century. Its dense homogeneous structure provides excellent durability properties, as shown in figure 1. Its compressive strength is more than 150 MPa, and tensile strength more and equal to 8 MPa. And it was recorded as well that the ultimate flexural strength of the product is 30 MPa. In terms of structural application, there are details. Details are shown in table 1. Okay, let's go to table 1. As you can see, many applications have been done by many countries, like US, Canada, France, Germany, Australia, Japan, New Zealand, South Korea, Malaysia, of course, Czech Republic, as well as China. In terms of the application, mostly are for superstructure, for road bridges, as well as pedestrian bridges, but a few for rail bridges, which is being done by China as well as Germany. Okay, apart from beam superstructure, the ultra high performance fiber reinforced concrete are being used as well for architectural facade and portal frame for buildings. Figure 2, let's go to figure 2, shows some example of being used for facade, like for example, like at Museum of European and Mediterranean Civilization in Marseille, France, and for footbridge of Peace in Seoul, in South Korea. Okay, let's go on. The establishment of the company. It started when a company by the name of Dura Technology Sendirian Berhad was established in 2006, where a factory was built nearby Meor town, about 17 kilometers away from Ipoh City. Okay, the name Dura is synonymous with durability, specializing in ultra high performance concrete. The company believes with the advancement of technology in the field of building, material, concrete can be innovated further, maximizing its potential and capability. DTSB, in short, aims to bring building material and building system into greener construction, best solution to achieve sustainable development goals at the minimal cost through continuous research and development for better product application. Okay, next slide shows the biodata of the founder as well as CEO for the company, which is DTSB. The founder is named Engineer Dr. Wu Yanlei. Okay, he is also the executive director of the company. He had his PhD in civil engineering in 2004 from University New South Wales, Sydney, Australia. He had 20 years experience in development of ultra-high performance concrete. He is also the adjunct associate professor at the university since 2016 till now, as well as adjunct professor of Swinburne University of Technology, Melbourne. He has published more than 80 publications, including a book on ultra-high performance fiber reinforced concrete, and he also holds 4 Malaysian Book of Records. Okay, as well as two awards, design awards for Best International Transportation Structure in the year 2016 and 2002 by PCI, Pre-Stress Concrete Institute, USA. Okay, now let's go on. When did actually JKR first embark into this new concrete technology? Okay, it was in 2008 when JKR organized its Senior Officers Conference, or in short SOC, in Ipoh, Perak. I'm born in Ipoh, so I can just tell a bit about Ipoh lah. Where an exhibition booth was set up and local companies were invited to participate and share knowledge of their product. Fortunately, at that time, DTSB was one of the companies who took part in the exhibition. Later, a factory visit was held by JKR Perak. I was at JKR Perak at that time. After the SOC, of course, for knowledge sharing session to witness, as well as to witness a proof load test on a beam which is being used for construction purposes. Okay, but it was only in 2010, after 2 years, in 2010, JKR Negeri Sembilan took the challenge in applying the ultra-high performance fiber reinforced concrete beam for the first time for the construction of a 50-meter span bridge across Linggi River at Linsong Town in district of Seremban. This bridge was completed and opened for traffic in January 2011, and it just took about 4 months to complete the project. A bridge which is 50 meters long and of 4 meters wide. Since that year, in 2011, many more bridges with ultra-high performance fiber reinforced concrete were built under the state and federal funds. The list of projects will be shown later. Okay. Okay, let's go to item 3, which is the ultra-high performance fiber reinforced beams application in JKR projects, and of course awards. Okay, in terms of design mix of ultra-high performance fiber reinforced concrete beam, table 2 shows the mixture or the content of the mix for grade C 140, 155. Okay. Let's show, the video shows how the mix is being done actually in the ultra-high performance concrete paste, whereby you can see the fibers are being mixed thoroughly. Okay. The table 3 shows the material characteristic values for ultra high performance fiber reinforced concrete for grade C140, 155, okay? So in every design of the beam for JKR project, for bridge projects, the material characteristics are as shown in table 3. Okay, these values are being verified by laboratory tests, and the results are shown in table 4, 5, and 6. Okay, table 4 shows the characteristic compressive strength, which is being carried out on several cube samples, and the value achieved was 155.24, and it exceeded the value of 155. Okay, and for characteristic compressive strength for cylinder, it is 151 against 140, which exceed the limit required for the concrete grade. Okay, for table 6, shows the result of the 4-point and 3-point bending test for flexural and tensile strength for grade C140, 155. Values are shown in red outline, and all values exceed the limits and comply with the required standard. Okay, figure 5 shows the layout of the bending test which were carried out for the purpose of verifying the grade C140, 155. Durability tests were also carried out, one of which is chloride diffusion coefficient. Okay, the result for Dura or ultra high performance fiber reinforced concrete is much better compared to the normal concrete used for structural components. Similarly, for water penetration under pressure, it is only 2 mm compared to normal concrete of 10 mm. Rapid chloride penetration test for ultra high performance fiber reinforced concrete, it is 35 coulombs compared to normal concrete of 100 to 500 coulombs. For abrasion test, resistance complied with the standard, and carbonation depth is 0 mm, which means no penetration for carbonation. Okay, in terms of standards for material design as well as construction, the French standards NFP 18-470, NFP 18710, as well as the execution standard. The P18470 is for material, for compliance of material for the mix. And for P18710 is the design which need to be complied specifically for ultra high performance fiber reinforced concrete. And the execution standard is to be followed during construction. Fortunate for JKR, since many projects have been executed using this product, JKR has also included the ultra high performance fiber reinforced concrete requirements in their JKR standard specification for roadworks, section 9, which is concrete. Okay, the photo shows the example of ultra high performance fiber reinforced concrete beams used in JKR projects. Basically, they are of I-beam, T-beam, or U-beams. The figure 8 shows one example of I-beam of 1.2 mm of height, 29.25 meters long. And the figure 9 shows the Dura U-beam, 2.5 mm height. Compared to normal concrete, definitely we use reinforcements, but for Dura beams, we do not use reinforcement, but we use only fibers. Therefore, no stirrups and shear reinforcement required. Okay, and then multiple segments can be joined with PT internal tension, and only we use dry joints. And SLS cracking tensor is 7 MPa. Okay, this is one example construction of bridge, which is the Manong Bridge, which is 300 meters long across the Perak River. It is 4 spans actually, which is actually it's 5 span actually, 45 meters along the first one, and followed by 3 spans of 70 meters each, and the last span is again 45 meters, so total is 300 meters. Formally, it takes 40 minutes to travel from one side of the bridge to the other, and after the completion of the bridge, it only took 2 minutes to cross the river to the other side. This side is the Sayong town, and the other side is the Manong town. These are the beams being casted at the factory. Sorry, I think it's hanging now. Okay. Inspection are being done at the factory just to witness whether there are cracks or not before they are being delivered to the site. Okay, this is the launching of the last 70 meter span of the Manong Bridge. Wow. The line is not so good this morning. Sorry, I think it's okay. Okay, these are the achievements and awards received for the construction of the Batu 6, Batu 6 bridge across Perak River at Bandar Riang Grid. As I mentioned just now, in 2016, the bridge was awarded the best international transportation structure in terms of design. The second award was the world first submersible ultra high performance concrete composite bridge, which is the Lambor Bridge, which is 404 meters long across Perak River as well. If you had the opportunity, maybe you can just go to the link here to witness how the bridge is being constructed from the start till the end. Okay, the link is as shown on the screen here. These are the awards received for the bridge, the Lambor Bridge, from TCI this year actually. Apart from that, the bridge also won the Road Engineering Excellence Award during the 11th Malaysia Road Conference, which was held on 11 to 13 of October this year. Since 2010, that was when the first ultra-high performance fiber reinforced concrete bridge was constructed. Till 2022, a total of 29 bridges were completed by JKR, and table 12 shows the list of all projects in several states in Malaysia. Okay, the first one of course, in Negeri Sembilan, then follows by a few in Perak. You can see here various type of beam or girder being used: UBG 1750, TBG 1325. Okay, the spans are all various span being used, and the loading type are being shown here: full HA 30 HB unit. And the construction period is less than a year. There are only 4 months, 3 months. We also have a UB of 650, a shallow one, in Rompin, which is 12 meters span and 4 meter wide, integral system. We also have pedestrian bridges, one of which is at Kuala Sepetang, which is 106 meters long, including the ramps. And we got item number 16 at Batu Enam, Kampung Rui Grid. It is a single span of 100 meters long without any piers in the river. And at the moment, this bridge is the longest bridge in the world that uses ultra-high performance fiber reinforced concrete as its beam. It is a single span of 100 meters across the Perak River. We have also a project in Kelantan, in Selangor, in Johor, and in Pahang. Those are the only states that have been used, that has used this product or this technology for their bridge construction. Okay, what are the advantages and benefits of ultra-high performance fiber reinforced concrete against normal concrete? One, ultra-high performance fiber reinforced concrete beam lightness reduces transport costs. Okay, let's see figure 19 here. 4 27.5 meter pre-stressed beam can be transported in one trailer compared to normal concrete beam, which can only carry one at a time. Two, ultra-high performance fiber reinforced concrete has superior mechanical properties and durability. As shown earlier, the compressive strength is more than 150 MPa, and the tensile strength is more and equal to 8 MPa, compared to normal concrete of 50 MPa, which is 2-3 times higher. And then ultra-high performance fiber reinforced concrete structure have very long service life and negligible maintenance. By looking at the surface of the beam, it can be seen that it's more aesthetic compared to normal concrete. And then number 4, it provides response to climate change, offers greater protection against heat, higher temperatures and fire, as well as protection against water or floods. And number 5, it promotes life cycle cost saving through non or significantly reduced inspection and maintenance requirements. Number 6, the structure is slimmer, tougher, and speed of construction. As shown from the list of construction, the amount or the time taken to complete a bridge, it takes only less than a year. There are 4 months, 5 months. The most is 24 months, which is, of course, a longer bridge, which is more than 400 or 300 meters long. We will take a longer time. And then higher sustainability measures, better global warming potential measurement, carbon emission and carbon footprint. By having a shorter construction period, the environmental impacts is very much reduced, and it's good for the surroundings, especially whereby you have a dense population or traffic congestion around that construction area. Leaving a true legacy infrastructure for future generations with a state-of-the-art infrastructure. Okay, table 13 shows the design life, which is beyond 150 years, even at more severe condition. Ultra-high performance fiber reinforced concrete is very suitable use in long span construction. Why? Of course, the longer the span, you need not have any piers in between the two support or the span. Therefore, it will reduce cost. You do not have to construct the piers as well as foundation. And then ultra-high performance fiber reinforced concrete provide minimal adverse time effect impact, as I mentioned just now. Shorter time period, less impact to the environment. And then it prolongs life serviceability due to its excellent durability property. Okay, figure 21 shows the comparison, cost comparison of conventional to ultra-high performance fiber reinforced concrete bridge. Okay, the red line here shows the normal bridge cost on average, and the broken line is the upper bound cost, and the bottom line, blue line, is the low bound cost for the normal concrete bridges. As you can see here, for ultra-high performance fiber reinforced concrete bridges, which is divided into driven pile, micro pile, and board pile, as shown in the figure here. So it seems that most of the bridges, whether it's using driven pile, micro pile, or board pile, mostly are below the red lines. Okay, which means to say that it is much cheaper in terms of construction for ultra-high performance fiber reinforced concrete bridge compared to normal concrete bridge. So in terms of cost implications, generally, ultra-high performance fiber reinforced concrete bridge has saving compared to normal concrete bridges. Okay, the saving percentage depends on locality, structure sizes, logistic, manpower availability. Initial capital cost is higher in comparison to conventional concrete, of course, but on the overall cost, it is much cheaper. However, the total cost benefit from the total asset life cycle significantly outweigh the cost implication as outlined in the benefit section presented earlier. For example, figure 22 shows the Sungai Guntung Bridge in Situ Terengganu, which comprised of U-beam or girder of 65 meters long by 40 meter wide. Let's compare the cost. Okay, the cost for foundation, okay, is 917 per meter square. Substructure 550 per meter square, and superstructure 2648 per meter square. So you can compare here. Okay, the overall cost is only 4,115 Malaysian ringgit per meter square. Similarly, for Kampung Teluk Kampung Baru Bridge in Manjung, as I mentioned just now, the longer the bridge is more cheaper compared to shorter or short span bridge. See, the amount here per meter square is only RM3504 compared to the earlier one, 4115. So in conclusion, the utilization of ultra-high performance fiber reinforced concrete in road and pedestrian bridge superstructures is no longer an infant stage in JKR. A total of 29 bridges were completed from 2010 till 2022. It is a proven technology which JKR has scrutinized its unique properties for creative and innovative design in road bridges in Malaysia, for example, the Lambor Bridge. Knowing its advantages in bridge construction, JKR has incorporated the utilization of ultra-high performance concrete technology in its standard specification for roadworks, section 9, which is concrete. In fact, JKR has also shared its experience with other departments like Ipoh City Council and Water and Irrigation Department or JPS in the application of ultra-high performance fiber reinforced concrete for road bridges. One such example of a JPS bridge is the Central Spine Bridge, which is 200 meters long by 17.4 meters wide, located along the East-West Highway in Greek, Perak. And recently, the Penang Port Commission or PPC has shown interest in the application of this concrete technology. Many ultra-high performance fiber reinforced concrete road and pedestrian bridges projects have been demonstrated by JKR in Malaysia. Besides the sustainable construction advantages for bridges in rural and marine areas, bridges constructed in urban areas of dense population and heavy traffic have also benefited from the low GWP and site environmental impacts due to reduced construction period. But all this while, this concrete technology are being used only for road and pedestrian bridges, but not yet for rail bridges. Therefore, it is hoped that this concrete technology be applied as well for rail bridges in Malaysia, because its application has many advantages over normal concrete in terms of its mechanical properties and durability. With that, I end my presentation. Thank you. Back to you, Mr. Abdul Zaki.
Abdul Zaki, terima kasih. Thank you very much, Mr. Meor. Very technical and informative presentation. My interest, I have a very big interest in concrete technology. And I see that JKR as a whole is doing a lot in advancing the usage of high-tech transformation, especially in the building materials, which is especially critical in this new age, especially when adapting to climate change and sustainability and so on. So first of all, I think I would like to open the floor to any questions from the participants. Let me see the chat room. There's one question from Dr. Andri. Salam Haji Meor, nak tanya, is there any risk of sudden failure due to extremely high strength concrete use?
Thank you, Encik Adri. Andri.
Andri, yeah?
Andri Kusbiantoro, right? Am I right? So thank you for the question. Actually,
Yes.
The usage of this product for bridges by JKR project, it has been already for more than 10 years, right? The first application of the product in 2010, and it's now already 12 years. Since then, there is no sudden mishap to any bridges, whether during construction or till now. In fact, the maintenance as well is very negligible. There is no maintenance at all for the bridge which has been completed for more than 12 years, which is the Linsong Bridge at Linsong Town. But of course, we have yet to see whether it is true that the maintenance will be negligible for many more years to come, right? For at the moment, it has been already 12 years, and the first bridge is still in very good shape, and no maintenance has been carried out so far. Thank you. I hope I had answered your question.
Okay. Thank you, Mr. Meor. Okay, Dr. Andri, menjawab soalan. There's another question from Mr. Vijay in the chat room.
Yes.
Is UPHC bridge girders still need to comply to the basic span or depth ratio as per code requirement?
Yes, it has to comply as stated in the French standard MPP 18-710 published in 2016. Yes, please.
Right. Thank you. Hope that answered the question of Mr. Vijay. Congratulations from Dr. Kamarul Aini. There's a question. What are the challenges during the installation of UHPFRC bridge?
Basically, the product are of lightweight. So you need only lightweight machineries to handle the lifting, the installation at the bridge site. So far, after constructing of 29 bridges in 12 years, there is no any mishap happen or difficulties faced during the installation of the beams for the bridges. Other challenges may be the environment, of course, but it won't be that affecting the progress of the construction because it is easy to handle the beam due to its lightweight property. Okay, thanks. And other one from Encik Kamarul Zaman.
Mm-hmm.
How about inspection, maintenance issues on the bridge structure? Use this concrete technology, especially for the pre-tension cable. Basically, there is no inspection or maintenance required once the bridge is being installed at the project site lah. So far, for already 12 years, there is no yet maintenance being carried out for the tension cable so far. But yet we have to see, for example, like the longer span bridge, like the Lambor Bridge, the Manung Bridge, as well as the Kampung Teluk Bridge, which is more than 200 to 300 meters long. And we have yet to see how the maintenance will be carried out after being completed for several years. Then
there's another question. A very interesting question from Mr. Skandar.
Right? Ultra high performance fiber system is saving site or more compared to the conventional method. Does the site worker require competent cert? Okay, the site people are being supervised actually. Okay, they are being supervised by the people from the product itself. That means people from Jura, they themselves come over to supervise how to install the beam onto the abutments or the piers. So it won't be any problem in case if the site workers are not that competent in terms of carrying out what need to be done at the site, because it's being guided by the or being supervised by the people from the factory himself, the designer himself, which assists in doing the work at the site. And the next one is instrumentation placed on any of the ultra high performance concrete bridge to monitor its performance in long term. So far, this hasn't been done. Well, it's a good idea to have this instrumentation just to check whether there's any deformation or failure or segregation on the structure itself. But in India, I came to know recently, what they did actually was, after the bridge is completed, okay, they place 8 or 6 numbers of trailers on the bridge and maintain it for 48 hours. And they check whether there is deflection or not on the beams. So after 48 hours, they come and check that, and the residual deflection is 0, which means to say it is back to normal. Although the 6 trucks have been placed for more than 48 hours. Example lah. So, but anyway, it's a good idea to have this instrumentation installed at the bridge site to check on the overall performance of the structure itself. Yes.
Thank you, Meor. Any other question from the floor? Kalau tak ada, from me,
Yes.
I can conclude that we can see that we understand UHPFRC is a very innovative approach towards all of us adapting to the climate change, sustainability requirements atau needs yang world is facing today. Concrete technology has been the core of our civilization, I think more than other materials. Finding the use of technology, especially in concrete, humans as we are now are able to build and live the way we live today with the use of concrete in our life. We build bridges, buildings, and of course roads. We build bigger, we build faster and more to fulfill the needs of humans. But despite all these benefits, still, this came at a very high cost. I think we see that many of our activity, especially in construction, while using high-tech or low-tech concrete technologies in our construction sectors, we still have a negative impacts towards the environment, still contributing a lot towards climate change and degradation of the environment. We are using a lot of finite resources, limited resources, and we are still producing a lot of waste. So my question is that, Meor, how do you see the future of concrete technology? What is needed to be done in the future in terms of more innovations and adapting to sustainability and our desperately needed actions towards sustainability? I think that what we have now is still not enough. So especially in these building materials, construction materials, or UHPC itself, how do you see it evolve and fit in the dreams of many, achieving a more balanced and sustainable world?
Thank you, Mr. Abdul Zaki, for such a very long question. Actually, one thing for sure, we need to do more research and development just to improve whatever technology that we have already achieved. That's for sure. For instance, like at the moment, we are using the grade C 140, 155 for our bridges. So why not use a better one, a better grade, so that we can increase the span, right? We can increase the span, and definitely when you increase the span, you need not have any structure in between, which of course better for the river lah, for instance lah, right? So less impact and cause flooding or whatever lah, which of course definitely if you have more piers in the river, that will definitely impact the environment, that will cause more flooding during after construction lah. So that is bad for the environment as well. So definitely we need to do more research to improve the product and don't stop there. For instance, like what I suggested just now, all this while we have been using this product only for road and pedestrian bridges. Like China, for instance, like Germany, they have used this product for their rail bridges. I can't see why in Malaysia we can't even use it for our rail bridges. So we need to have to be brave enough lah, okay, to use this product elsewhere. For instance, like I said just now, for rail bridges. In fact, I've made a research during my master's degree comparing what happened if we were to use this product for rail bridges. So in my paper, I did show the comparison that it is possible. In fact, it is possible to make use of this product for rail bridges, which is less cost and of course more durable and longer lifespan. Therefore, I think we have a better future in terms of this concrete technology if we dare to use it, right? We dare to use it for our bridges and in Malaysia lah. That's all.
All right. I think the dare should be accepted by all of us, especially the academic staff and the students, and take this challenge and bring it to the new level. I think the cry of the earth has been heard for so long without any positive actions or more stronger action from us human beings as the Khalifah of this world. So again, thank you very much, Mr. Meor, Haji Meor, for addressing this interesting topic and for answering all the questions. On behalf of ICIW FTK, I hope that all of us present today has learned a lot. Of course, we learn a lot. We myself learn a lot, and above all, I hope that not just understanding the benefits of the new products, the technology. I hope all of us today in this session are all inspired to seek a better, sustainable world in the future. So from me, once again, thank you very much to everybody for participating. And thank you, Mr. Meor. And I hand over the session back to Akilah.
Thank you so much, Mr. Zaki. And have a nice day.
Thank you for the nice sharing. We hope this sharing session can provide beneficial knowledge to all participants. Kindly ensure all participants fill up the attendance form as per attached in the chat box Zoom or Facebook comment. We would like to invite ladies and gentlemen for the online photography session. We are all asked to open the camera.
Okay, ready. 1, 2, 3. Okay, one more. 1, 2, 3. 1, 2, 3. Okay, last one. 1, 2, 3. Okay, thank you.
With that, we end our slot 1 for this morning session. Thank you and see you again in the slot 2 at 2 p.m. Bye.